The year is 1938. Two scientists, Lisa Meitner and Otto Frisch, make a startling discovery. They unlock the secrets of nuclear fission, splitting the atom and unleashing unimaginable energy. This breakthrough, born from scientific curiosity, casts a long shadow. The world is on the brink of war. World War II becomes a crucible. Nations pour resources into harnessing the atom's power. The goal, a weapon to end all wars. In 1945, the United States successfully tests the first atomic bomb, Trinity, in the New Mexico desert. The world watches in awe and terror. The bombings of Hiroshima and Nagasaki follow, horrific demonstrations of the atom's destructive force. These events mark a turning point in human history. The world enters the atomic age, forever marked by the specter of nuclear annihilation. The Cold War intensifies the nuclear dilemma. The United States and the Soviet Union engage in a perilous arms race. Each side amasses vast arsenals of increasingly powerful weapons. The doomsday clock, a symbol of global vulnerability, inches closer to midnight. Nuclear weapons derive their power from the atom's core, the nucleus. Within this tiny realm, unimaginable forces hold sway. Nuclear fission, the process of splitting atoms, releases this energy with terrifying force. Imagine a single uranium atom, heavy and unstable. When struck by a neutron, it splits apart. This releases energy and more neutrons, triggering a chain reaction. In a fraction of a second, billions upon billions of atoms fission. The result is an explosion of unimaginable power. There is another, even more destructive process, nuclear fusion. This is the power source of the sun and stars. In fusion, light atoms like hydrogen isotopes are forced together under immense pressure and heat. They fuse, forming heavier elements and releasing colossal amounts of energy. Thermonuclear weapons, or hydrogen bombs, utilize fusion. They are thousands of times more powerful than fission bombs. Their destructive potential is almost beyond comprehension. The creation of nuclear weapons is a complex and dangerous process. It requires expertise in physics, engineering, and materials science. The core components are highly radioactive and must be handled with extreme caution. First, fissile material must be acquired. Uranium and plutonium are the most common. These elements are found in nature but must be enriched to increase the concentration of their fissile isotopes. This process is technically challenging and expensive. Next, the weapon design must be finalized. There are two main types: gun type and implosion type. Gun type weapons fire one piece of fissile material into another, triggering a chain reaction. Implosion type weapons use explosives to compress a sphere of fissile material, achieving critical mass. Finally, the weapon must be assembled and tested. This is a highly sensitive and dangerous operation. The consequences of an accident could be catastrophic. Once assembled, the weapon is ready for deployment, a chilling reminder of humanity's destructive capacity. The development of nuclear weapons has had a profound impact on global politics. It has created a new era of international relations, one defined by the constant threat of annihilation. The balance of power has shifted irrevocably. The concept of mutually assured destruction, or MAD, emerged during the Cold War. It posits that the possession of nuclear weapons by multiple states deters their use. The logic is grim. Any nuclear attack would trigger a retaliatory strike, ensuring the destruction of both aggressor and defender. However, MAD is a flawed and dangerous doctrine. It relies on rational actors, perfect information, and the absence of miscalculation. The Cuban Missile Crisis of 1962 demonstrated how easily misperception and miscommunication can bring the world to the brink of nuclear war. The proliferation of nuclear weapons remains a major concern. The more states that possess these weapons, the greater the risk of accidental or intentional use. Terrorist organizations seeking nuclear capabilities add another layer of complexity and danger to this volatile landscape. We stand at a crossroads. The legacy of nuclear weapons is a double-edged sword. On one hand, the fear of their use has arguably prevented large-scale conflicts between superpowers. On the other hand, the very existence of these weapons poses an existential threat to humanity. The shadows of Hiroshima and Nagasaki still linger, a stark reminder of the devastation these weapons can unleash. The environmental consequences of nuclear war are equally dire. A nuclear winter, triggered by widespread fires and dust clouds, could plunge the planet into darkness and famine. The path forward is fraught with uncertainty. Disarmament efforts have been met with mixed success. International treaties and organizations work to limit the spread of nuclear weapons, but the challenges are immense. The future depends on our choices. We must find a way to move beyond the era of nuclear terror. This requires dialogue, diplomacy, and a shared commitment to a future free from the threat of nuclear annihilation. The survival of our species may depend on it.